Good luck, guys.
Love you
Cool.
all.
Hopefully your guys or ladies' games went well this morning, unless you're watching it before, in which case, good on you. That's cool. All right. Yesterday in class, remember we looked at that test, right? That's my bad. Participation points taken from me. Okay. Going through it, we looked at the test in detail, and did we look at either of the problems? We looked at one of the problems from the homework, right? Number 3? Okay. We will look at number 4 together today, and then I'm going to give us a chance to get a little bit more practice with them. I don't know. We'll see. Anyway, yesterday we were looking at number 18. Is that right, from the test? Yep, we have something sliding down. The only thing acting on the block that's sliding down this incline, gravity is pulling it down the x direction, down the ramp. And then what was counteracting it? The normal force doesn't counteract because it goes opposite, like perpendicular to the ramp. But something was counteracting it. If you have, and I'll draw it all out again, and I'll actually change colors. Here's a block, and I'm going to draw like a physical block so I can add stuff to it. Okay, we're just going to say its position's at 0, 0, though, just so it's convenient. Okay, gravity in the x direction, or Fg of x, pulls it down this way. Everybody good with that? What slows it down? Friction. Force of friction. And since it's moving, is it kinetic or is it static friction? Kinetic. Okay, here's gravity pulling downward. And then here's the normal force right here pushing up from the box. Okay, looking at that, the situation isn't that crazy, except, I mean, really it's not that crazy. I don't even need any numbers because we're going to do the algebra method. Now, we didn't do a problem challenging enough to see this shortcut as we went through the chapter, so we didn't use the shortcut anywhere. But do you think we might see friction stuff again at some point? It'll probably turn back up, would be my guess. Which means we are now going to develop a shortcut and probably forget the shortcut in the subsequent, Christmas break. That's forever. And then have to remember it later. But that's okay. Looking at it, what I know right now is where I left you yesterday. The net force of this system in the x direction is where we're looking, is exactly equal to the force of gravity pulling it down the ramp in the positive direction, and then minus what's fighting it? Friction. Okay. Looking at this, what's the net force and why? Why? Somebody help. It's constant speed. It's not accelerating. Now, the algebra part of this is what I care about. There's a little bit of algebra, a little bit of trig, way more algebra, just so you know. But let's plug in. That's a 0. What should I add to both sides right off the bat? So I'm going to add the friction. So we wind up with this expression. F of friction kinetic, the force of friction, is exactly equal to the force of gravity in the x direction. Everybody still on board? Now, when you guys are working problems, purely out of curiosity, if you were doing this problem, we didn't write down all the knowns, how soon do you reach for your calculator? Does it happen like right at the beginning where you start plugging in stuff? Some of you, yes, I would assume. It feels unnatural to do, but we can do everything but the very last step without touching our calculator. We only need to touch calculator a single time. One enter is all I need on the calculator to solve this problem. Okay, we're trying to find, just as a reminder, mu k, right? The coefficient of kinetic friction. Cool. So let's just start plugging and chugging. And there's going to be a lot of definition stuff, or kind of definition. How do you find the force of friction? And this is the definition-y part. If you need to check your notes, you can. Say it again. Oh my gosh, love it. It is the normal force times the coefficient of friction. So this left side in our first substitution becomes this. Okay, I'm going to leave this one here for now, and we'll change it in a minute, okay? Everybody on board with what we've done so far? This is this. Cool. Well, I want to keep expanding because I don't want to have to plug stuff in yet. How do you find the normal force again? And just to remind us, there's a theta somewhere in here. You tell me when to stop so I can put theta in the little angle that I'm in. Right here? I'm just going to call it theta for now. Kind of hate the way that theta looked, so we'll call it theta again for now. Still hate it, but that's okay. Cool. How do you find the normal force? So sort of. If it were a flat surface, I like that idea. Don't draw this one. It's going to be obnoxious and ugly. Gravity pulls here. If you just say the opposite of gravity, here's friction. Or sorry, here's the normal force. Is that where the normal force is on an incline, though? So this is where we have to rely on that little bit of trig stuff. And there's a bunch of different ways you can do it. This is my normal force that I'm after, which coincidentally coincides exactly with either this vertical distance on that right triangle, or if you'd rather, this vertical distance on this right triangle. Now, most of us seem to have used this one, typically, and that's the one you're more comfortable with because it's the one that shows up first. Okay, I want to find the length of that green vertical line, and to say vertical, I'm just going to dash this one or make it really tiny. So you just barely see it, so there's my right triangle. So it's right there. There's a right angle. All right, if I want to find the force of gravity in the y direction, which is this green one, let's just look at this triangle. How would you find this force of gravity? How do you find any force of gravity? Mass times gravity, right? That's this line here. So I'm just going to sketch it on my triangle real quick. mg is right there. And we need this one, right? So this is Fn. It's opposite of Fn, but we'll change the sign here in a minute. It's actually going to give us a positive just because how we're looking at stuff. So that's just Fn. What trig function could we possibly use if we know theta and we know, like we don't have a number for it yet, but we have the mass of the object, right? Can somebody confirm that? Do we know gravity? Okay, so I could know the length of this. I just haven't written a number yet. Gosh, from this angle, what two sides are we looking at on the triangle? Adjacent and the hypotenuse. So, katoa. One more time. Cosine. So if we need a little bit of scratch work, I will do it over here in this lovely black color. Cosine of theta on that triangle. And some of you will likely skip this. Can you see that when I write with that fine of a thing? Okay, cool. Cos theta for this triangle, how would you find it? It's what over what? So what's the adjacent? Are you sure? I mean, it is adjacent to it. It is next to it. You're not wrong, but you're not right either. Because there's two sides that are adjacent to any angle, right? Like, there have to be because there's two sides to it. However, mg is not the adjacent side. How come? It's the hypotenuse. So remember, Sean, our right angle goes against this, which means here's my right angle, here's my hypotenuse. Hypotenuse here and adjacent side here. It is. This is the longest one. It's opposite from this largest angle, the right angle. We are. This is theta. Do I need to draw it bigger? Is that where it's getting goofed up? Okay. So adjacent is this, hypotenuse is this. Everybody cool with that? Okay. So adjacent over hypotenuse tells me the normal force over mass times gravity. Cool, cool. Okay, which means I know that the normal force that we're going to plug in here in just a second, and I'm going to start doing this. We're going to call this alpha, because I'll just make sure I can see this equation later. Fn is what? I don't know why that's a lowercase n. That's weird. mg cos theta. I just solved it for this by multiplying by mg. This here then gets replaced, and I'll just do this. There's alpha. That's that equation that we're going to use. And we'll go back to purple here. We now have mu k times mg cos theta is exactly equal to, here's my force of gravity in the x direction on that other bottom part of that triangle. Now, I'm always going to use a hypotenuse because I don't have to round whenever I calculate it. Like anything else that I type into the calculator, there's going to be decimals. And realistically, if I go like 4 decimals, I'm going to be accurate and precise enough for any application that you could ever do. But I'd rather use the one that I don't have to approximate. So I'm going to use the hypotenuse still. From that angle theta, and I'll draw this triangle bigger just in case that was the issue. Here's our lovely triangle that we're looking at. So it's that where we just saw that this is my right angle. That's the y-axis. Here's mg. Here's the normal force. And here's the force of gravity in the x direction. What's up? No, that's okay. I made it really faint so that eyes would be drawn here. But I should have redrawn it. Okay. I don't remember what this angle is, but what trig function do we use to solve this? Opposite and hypotenuse. Okay. Without rearranging stuff the same way, it'd be the same problem just with sine instead. Anybody opposed to me just blessing you, first of all? And second of all, just saying that, gosh, I think we can find FGX pretty easily. It's the exact same process, but instead of cos theta, what's it going to be? Sine theta. So mg sine theta. Cool? I'm good with it, or you want to see that work in between? Good? Okay. Which means I'm going to write mg sine theta right here. Are your spidey senses tingling yet? I want to solve for what again? Are you sure? I'm looking for mu k, right? Oh my gosh, look at how unbelievably nice this is about to be. Who haven't I called on? Kalisha, what can I divide both sides of this equation by? I'm trying to solve for mg. You don't have to think about that part. I want only mu k over here. Sure, I'll do cos theta. I would probably do more steps than just cos theta, but I'm totally fine. Ooh, mg cos theta? If I divide, weird. If I divide the left side by mg cos theta, mg cos theta, and I divide the entire right side by mg cos theta. Dig on. Anything else? Dig on. And oh my gosh, look at how nice this becomes. Mu sub k is apparently equal to sine theta over cosine theta. If you get to this point and stop here, I'm good with it. You still only need one enter. Does anybody recognize that sine theta over cosine theta has a different name? Tangent. Hey, look at this. If you're on an incline, we get a handy shortcut. Now, if you get the shortcut, cool. If you don't get the shortcut, equally cool. Here's my suggestion, and it's just a suggestion. I wait probably longer than any of you in here realistically to plug in numbers and things. Most people plug stuff in earlier because it makes it look and feel a little bit easier. But here's my thought. If you were to actually take this and hypothetically, without showing any work or with it, you were to ask your calculator mg cos theta, and you're asked to plug in a number. I don't know what it is. I don't have it written down. I don't really care. Can I just make up a number for now? If this came out to be 43.15, and then you did mg sine theta, and it came out to be 44.17. I'm making stuff up. Would you have ever realized that m and g divide out? You would just never even see this as a possibility, because if you plug stuff in, you lose sight of what's the same. Now, if you were deciding to be really specific and write every number without multiplying it, what was the mass? 51.02. It's possible that you would write it like this, but I don't think anybody in here typically does. 51.02 is this mass. Gravity is 9.8. And cosine of, I don't know, anybody know the cosine of 25? Somebody gonna have it somewhere. One more time, 5 times louder. 0.9063. Okay, equals, if you didn't type anything into the calculator and just replaced with numbers, in this situation, you might recognize, this is going to be much smaller, 0.1 something is my thought. Maybe 0.2. Gosh, dang it, I'm so far off on trig. Okay, if you wrote all of them out like this, Maybe you recognize that you can divide both sides by 51.02 times 9.8, but nobody's going to write it like that. If you have these numbers, you're just going to use your calculator and multiply it. If you hold off just a little bit longer than feels natural, you'll see often, this stuff just falls out. Cool. Doable? The shortcut's cool, but it's important to see where it comes from. Nice. All right. I want you and your neighbors, or you rather, I'm going to give you nope, I lied. We're going to jump right into the next problem because we have people leaving at 9, and then we'll do a little thing. I'm not skipping it just because you guys are gone, but I'm cool. All right, let's go back to problem 4. We're going to make sense of it. We're going to do it. We're going to knock it out. Questions on here, I guess, before I move forward? Mass times gravity. Or the force of gravity, if you'd rather. I can't tell if that's a nod oh, okay. All right. So let's look at the last problem on that worksheet, and then we'll jump in, and I got to find it and open it because, whoops. Known. 2 things is it. Theta is 51 degrees, and delta x is 14 meters. That's it. Now, I'm going to make a switch, and you do not have to, but I'm going to look at unknowns, and then I'll just put a star next to the one that I'm actually trying to answer in the end, because we're going to have a bunch of unknowns. Right now, do you have an equation that we can solve for, we're looking for the speed must the player give the ball, so VI is what we're after. Notice there's no x, there's no y, it's just the total vector. It's just this. Don't know it. Okay, well, bummer. Is there a way using any of these equations that without knowing time, we can solve this? Don't know time. I don't know the initial velocity. I know it's the same as the final velocity, so I kind of have that going for me, which is nice. But there's nothing that I have here that can work, I don't think. Now, if you didn't recognize that, that's okay, because you're probably going to start trying something. Don't care what it is, but if you try anything in this problem, you're probably going to take a step that's going to be required. I don't know where we start. Talk it out with your neighbors. I'm going to call in one random person. Where do we start? What's the first thing we want to do? I don't know time. I don't know delta y. I don't know. I do know a couple more things. What's AY? So I'm going to call it negative 9.8 meters per second squared. What's a sub x? 0 meters per second squared. So I did know a couple more things, but I don't think I can make these work. Talk with your neighbors, 30 seconds. Find any equation that you want to try. We'll try it. If it fails, that's okay. We'll just try a different one. There's only 5 choices, and really there's only 3 choices because these are all the same. 1, 2, and 3 are the same equation. Cool. Talk it out. Take a pick, and we'll try it out. Okay. So Nick suggests use number 2. I'm fine with that equation there. Are we working in the x direction or the y direction? Or, just looking at it, we could, nope, you guys wouldn't do that. Okay, x or y direction? Because we need a direct, just kidding. Okay, so we're going to use in the y direction. So, looking at that equation number 2, and we're just going to try it. If it doesn't work, we're not going to erase it. We're going to cross it off and try something else. Cool. So this is equation 2 from our list that we have. I'm going to do one thing. I'm going to subtract the x sub I or the y sub I over right away, so I can just call it delta y. Cool. So here we go. Delta y is exactly equal to Vy initial times time minus 1/2 at squared. Is that the right equation? Nope, sorry. I got mixed up as we were going. So VF, okay. So VFy squared minus VFI squared all over 2a. All right, that feels a little better. Cool, love it. Let's try it. Do we know delta y? Don't we? Now, here's the other part. There's so many little pieces that you can consider differences with these problems that there's just no way avoiding it You have to be able to think about them. When I talk about the change in y, where do I start? Like, I'm a basketball player, right? So I'm starting, and I'm going to start counting my y position where? Based on this problem. As soon as it leaves my hand, and I'm going to use Tolly's advice, I'm going to call it 0. So check it out. Here's a basketball, right? Shoot. It's going, it's going, it's going. You tell me when I'm at my final spot. So it's the same height, right? That's what we're told. Or did you want to stop doing it? Could we do either? Do you know the final velocity of here? At the very top of its path? We do know it's 0. Do you know, kind of, the velocity over here? Ooh, love it. It's a negative, the same as what you started, right? Okay, just to make sure that that clicks. When you throw something up, it leaves your hand at the exact same speed that it comes down at the same height. Which means, if I know that right here was VIY, then this right here is going the exact same size, just the opposite direction. This is VI or VF, but this is negative VIY. They're the same number. Now, with that in mind, maybe we can try this out. Cool. This still just stays VFY squared, right? Okay. Gosh, maybe there's a better way to write that, but we'll see. What's delta y then in our situation if we're doing the whole path? Okay, so I'm going to write that down here. Got that out. Do you want me to write 0 or can I write delta y? Delta y for now? Okay, I guarantee the next one I'm going to write 0. All right, let's think about what happens here. VF y squared. Well, how would you... I don't know. We'll just leave it like that for now. Minus, what did we just notice? Whoa, do you guys see that I did a wonky thing here? VFY and VF. No, I didn't do anything wonky. I thought that was another. Wait, yeah, I did. What should this be? It should be VIY, shouldn't it? Do you guys see what I'm changing? That's not final initial. That doesn't make sense. VIY. There we go. Okay, what do we just substitute, though? And maybe we could rewrite this. I just wrote the exact same line, didn't I? Golly. You want to erase one little thing real quick? Since we already have it. I'm getting goofed up just as I'm writing it. What did we just say VFY was? Negative VIY. So I'm going to substitute this value with negative VIY squared. Because I know they come down at the same path, I'm good with that. Over 2a. Now we're going to start playing around with this. You guys love fractions? Not really. What can I multiply both sides by to get rid of that fraction? And we're going to see something wonky happen, and that's okay, because we're learning the process. I'll multiply both sides by 2a. What happens here? It's not a fraction, but it even gets nicer. What's negative VY squared minus VY squared? Negative 2 VIY squared. Now, Fern and Mickey, if you guys want to peace out, the video will be here. Cool. If you want to wait a minute, I'm also fine with it. Yep. I can talk to you guys specifically during pre-calc as well if you want to see this done, or the video, either one. Why doesn't this work? Anybody tell me that? Delta y is 0. Well, that's what we'd obtain, right? But check it out. If I make this claim, the initial velocity in the y direction was 0. What's going to happen with this basketball? Can you shoot a basketball with no initial velocity? No, it'll never leave your hand. This is a good try, but it didn't work out in the end. Bummer. Don't erase it. It's part of the process. Okay. Well, Nick, thank you for that. It's a good thought. It almost worked. I would like another option then. So I'll tell you, if 2 didn't work, just by virtue of what these equations are, which ones are also out all of a sudden? 1 and 3. They gone. So it has to be 4 or 5. Which one do you guys want to try first? Okay, let's try 4. In the y direction or the x direction?
What?
Okay. So number 4 in the y direction. I'm good with that. Number 4, I'm going to change this to delta y again. Delta y is equal to VIY times t minus 1/2 AT squared. I wish I had a marker that I could write on these desks and it wouldn't disappear, and then I could erase it later somehow, so that we could just write all these equations on every single desk. I don't, but if anybody has an idea for that, hook it up.
Just
All right.
a Sharpie and then something wet.
I'm not sure. We'll do it. I'll do a sample spot on one of them. Will it work?
I think alcohol was good enough.
I'll try it out. Cool. All right. I want you guys to try to solve this one for t. Don't plug in any numbers anywhere. See if we can solve this for t. Or, yeah, let's solve it for t. I'm fine with that. I'm going to give you one piece of advice. What do we still know this is? Cool. It is still 0.
How is that one 0?
Because if we shoot a basketball and it goes in the hoop at the same spot, what's our displacement in the y direction? So here I am shooting, let's leave my hand, and it's hitting the basket. And it's specifically because this.
Yeah, at the end of it, you mean like the ball isn't any higher than it started?
Correct. There's no displacement in the y direction. I don't think, you say it's still 0? I don't know that I agree with that, but I might have misheard something. What can we do to this to like start playing around with it? Rearrange it. What's the natural first choice? Say it again. Oh, I wouldn't take square root yet. I forgot it. Okay, we could add the 1/2 AT squared, right? Or subtract the VIYT. Or, gosh, what are we really looking for? We could look for time. I'm fine with that. Well, it's set equal to 0 right now, right? And check this out. It's a quadratic. It's written a little bit differently, but this is t squared plus t plus a constant. The constant is just 0. Oh my, quadratic. Well, what's that F word we're going to use in here? That's a good F word. What could we factor out of that expression? Just to make it a little bit simpler. Ooh, how do you take a half out of VIY? So you could. I'm not going to yet. We'll get there. We're trying to solve for t, right? What do both terms have in them? Can I factor a t out of these? Okay, let's try that. And I know it might not seem like it's doing a ton, but t and we're left with VIYT, just VIY, I'm sorry, minus 1/2 AT. Everybody okay with that? Here's what's going to feel weird, and this is part of the magic trick. We're not going to get an answer yet, but we're going to get half of our answer, and we're going to see why here in a minute. I can solve this for t because I know the angle and we'll know the acceleration in the y direction, so I can deal with most of this. This factor right here, just a single t, it works to make this times this 0 if and only if t is equal to 0. If it takes a little scratch work, I'm cool with it. Solve the other side of it for t as well. T is either 0 or it's going to be something else out of this factor, which you may need a little scratch work. Solve that factor for t as well. Most of you will probably need scratch work.
Will the acceleration be in the y direction?
Yep, because we're working everything in y right now. So the scratch work that I'm talking about if we are taking this thing, and I'm going to do it here. I'm going to erase it in a second. If I'm taking this and I'm trying to set it equal to what? 0, right? Because here's our 0. We're trying to solve it for t, which may be what you meant. Maybe. I can't tell for sure. What would you do if we want to set this equal to 0 and solve for t? Can I add this to both sides? Okay, and then I'm going to cheat. This is me doing it. I just added that to both sides. Multiply by what? So if I multiply by 1/2, this becomes a 1/4. What undoes a multiply by 1/2? A 2? Okay, and then I'm going to divide by one more thing. That piece is gone now. Over a. Everybody on board with this expression for t? Now, it's awful, and it looks terrible, but we just found that t is apparently 2 VIY over a. Do we know acceleration? We don't know VIY yet. Maybe we can get there. Now, this one we were actually able to get something out of it. I'm okay with it. I'm going to look at this, and why did I solve for t? Like, why am I thinking t here? Anybody have an idea? Yeah, if we figure out how long it takes, we're going to be able to work some more stuff out here in just a second. But here's the other piece that I want to make sure that's clear. We just found the time it takes in the y direction, right? So that's the time that it takes to go all the way up and all the way back down. That's t. We're asked to find how hard the ball is launched, right? And we get an angle. Does the ball also, instead of just going straight up and straight down, that path, does it also make this path from 14 meters across? And when it does that, how much time did it take? You won't give me a number. It's the same time, right? It has to be. Now, if you were to calculate it, though, we're not going to do VIY if we're working in the x direction, are we? Doesn't make sense to do that. So here's my suggestion. I think that we have a good value for time from y. Can we get a value for time from x as well? Because if we have two expressions of time, that gives me two equations with a couple unknowns each. Holy system. We are going to, and by we, I mean you and your neighbors, right, meow, are going to solve for t in x dimension.
How does t equal 0?
So it won't really. It's just this, the question that we're looking at is, when is the displacement 0? That's what we really just solved. And check it out. Here I am. I'm about to shoot it. Almost about to shoot it. What's the displacement right now?
0.
And then the other one is 0 all the way over there. So it happens before we start and at the end of the path.
Okay.
Cool. I'm going to pause this. If you need to stand up, stretch, move around, talk with people that you don't normally talk with, feel free to do so. I want you to find me an expression for time with x in it instead, because we have y right now. All right, so just to make sure we're on the same page, delta x, and I'm using equation 4, is VIX times time, right? Plus the acceleration, but I'm not going to write it because why? 1/2 0 t squared, and it's just gone. Okay, can you solve this for time then? Okay, now, here's the magic part of it. When we're dealing with this, the fact that the time in both dimensions has to be the same is going to be our in to solving problems like this with substitution or systems of equations. I know the t there that we just got, delta x over VIX, is the exact same number that this has to spit out. Exactly the same number. They have to be the same number because it's the same amount of time in both situations. It feels silly to do, but we're going to put them together. I wouldn't normally write this, but let me know if you guys agree with this following statement. It's kind of controversial, so don't hold it against me. T equals T. Right? Like, definitely true. Hey, look, I have a T and I have a T. Let's try to set these equal real quick. And let's just see what shakes out, and then we'll make sure that we're on the same page, what we're looking for. All right, so I know that on the left, I'm just going to call it this, 2 VIY over A. 2 VIY over A. And I'm alleging that's exactly equal to delta X over VIX. Everybody still on board? Like, you might not see the end picture quite yet, but do you understand how I'm allowed to do this? Okay. We're at a point now where one little shove, and I think that with collaboration, you'll be able to get it. You guys are going to finish this problem. At least try to finish it. And I'm going to work it. I'm going to give you a head start. What are we actually after in this problem? Say it again. VI, right? The initial velocity. Not in the x direction, not in the y direction. I don't have just VI written anywhere in this expression yet, do I? Is it kind of hidden in there, though? Because if you want to find either component, like in this triangle, if here's VI, how would you get this component of it? Times cosine, right? Because cosine's the x direction. This is VI cos theta. And this is really VI sine theta. We know that those are the components because that's how we decompose vectors. I want you to plug in these for here and here, and I want you to try to solve for VI. I will write one last step, and I want you guys to try it. I am replacing the x velocity with this component and the y velocity with this component. Solve this. It looks ugly for a second, or for a lot of seconds, maybe. Am I right? And what are we trying to solve for? So what would you do? If I want only VI on the left side, forget about, like, let's keep it squared for now. How do I keep it so my next line says something like this? VI squared equals, I gotta divide by something, I think. So sine cos, one more piece. That 2, right? Kalisha, your whispers were perfect, just so you know. Like, your answers were good. You don't have to whisper. All right. Now, at this point is where I'd reach for a calculator. I would actually do one more step because I'm pretty comfortable with my calculator. But just check it out, and let's just look at this. The only acceleration that we have in this problem is in the y direction. So I have not been writing it. I'll just call it A if it's just the only one that's there. Do we know delta x? It's 14. Do we know A? 9.8. Do we know theta? Oh my gosh, check it out. When we plug in, if we do so at this point, delta x is 14. Acceleration is 9.8. I know that this is 2 sine theta cos theta. And I think that we can probably solve this. There's one, oh sorry, sine of, not theta. What should I replace that with? 51. Okay, if you are typing this in one line, the most important thing about your calculator is parentheses here. And really, those ones aren't as important. I'm going to take that back. No, it's good practice. Parentheses there and parentheses there. Or just do the top and then do the bottom and then divide them.
Does that work?
I don't think so, but you can use the black one. I don't know where my HK5 calculator went. It's somewhere. You get 140? Okay, there's 142. All right, so love it. VI squared is 142 point something.
Oh, that you know?
I don't think so.
140.2.
140.2? Okay. Something. And VI then, gosh, that's almost 12. 11.8?
Did you have to square root?
I did. And we're done. Okay, for this, I'm not going to give you any homework tonight. This math is the heaviest by far that we've done all year, by a long shot. The concluding statement that we have time to write now, or we can write it first thing in our notes tomorrow, if you are solving projectile motion and you don't have the initial velocity, this system, setting time equal to time, is going to be the technique most of the time. I should not have used that word there. It is usually going to be this technique. As you look at it, this problem took a long time for us to work through. That's okay. It will not take this long in the future as long as we know that, hey, time equal to time as a system and we can solve it. It is super easy. It's not super easy, but it's much easier. I want to highlight here as you guys are packing up, I used 4 because that's what you guys suggested. If I had tried to use this one and I had VYF, which is just negative VIY, equals AT plus VIY, we're going to get this expression right here without having to do any factoring. We wouldn't get the 0. I would have gotten, subtract VIY, so negative 2 VIY equals negative AT, because that's my acceleration. And oh my gosh, we get the same exact thing. AT over, whoa, I solved for the wrong thing, but we're going to get the same piece. Cool. Tomorrow, bring your work clothes, I guess, because we're going to work tomorrow.